All right, we're live. So piecewise functions are one of the topics that you're going to see throughout this homework unit. A piecewise function usually looks something like this, where it almost looks like three different functions all kind of jammed into one. And in fact, that's exactly what it is. A piecewise function will usually be written like this. We'll call it something like f of x. But then instead of just having one function, we have three different functions that apply for different domains. So the first one on the top says our function is equal to -2 if x is between these values. And if we look at our graph, between the values of -6 and -3, we do have the function x is equal to -2. So that is just the first piece of our three-part function for this domain. Now, I want you to also pay attention to these symbols. If the symbol in our domain is a less than or equal to symbol, we're going to have a filled in dot. That's where that's going to be included in our domain. On the other hand, if you just have a less than symbol with no equal to component, you're going to have an open dot, and that would not be included there. All right, so I've actually taken some time to write out what all three of these separate functions are. For the domain between -3 and 2, we're going to be dealing with this absolute value function right here in the middle. And for the domain of between 2 and infinity, we're dealing with this line that kind of goes down and down and down forever. It's got that arrow at the end. It's kind of hard to tell that that's an arrow, but I promise that is an arrow, not a point. Okay, so that was just some background information about what a piecewise function is and what it looks like. Because it's such a jumbled mess of three different functions, it makes certain things kind of challenging, like even just evaluating a point. So for part 1 here, where they ask you to evaluate f of -5, -5 would be our x value. So what we would do is we would go up to our domain and figure out which one of our three domains -5 fits into. Well, -5 is in between -6 and -3, so it would actually be the first domain that we would look at. So we would take -5 and we would plug it into our first function for x. Well, this one doesn't happen to have an x, so we don't have to plug it into anything. Instead, f of x is always equal to -2 for this domain, so we would just put -2 as our answer. Now that's the algebraic way of finding your answer. You can also just use the picture. So f of -5 is where we would go to the x value of -5, 1, 2, 3, 4, 5, and then we would find our y value, which happens to be right here at -2. All right, so for the next example, they want us to find f of -2. So this time we're plugging -2 into our function. That would be in this second domain. And if we plug -2 in for x, you would take the absolute value of it, which gives you +2. So we'd end up with 4 minus 2, which gives us 2. Or we could do this graphically. We could look at -2 on our x values and see what y value that gives us, which in this case is +2. All right, next example, we're going to plug in 2 for x. Now, this is a little bit tricky because both of these domains contain the number 2. But since we're plugging 2 in for x has to be able to be equal to 2. So it's this symbol, the less than or equal to symbol, that we're going to be using, not the strictly less than symbol. So it's actually this second domain that we're in. So we're going to plug 2 in for x on this function, which is going to give us 2 times 2 minus 2, or the same thing we just ended up with. Now let me show you graphically what just happened. If we plug in 2 for x, that means we're looking at the x value of 2. We kind of have two options here. That's sort of because of this feature, where 2 shows up in both of these domains. But down here, this is an open circle. This represents the fact that the value of 2 is not this point. Rather, we need to be looking at the filled in circle, which exists up at +2. So 2 different ways to approach the same problem. That's how you get your answer. All right, I've made a ton of little notes here. I'm going to erase some of these. All right, finally, they want us to plug in 4. If we put 4 in for x, we're obviously going to be in this domain, so we get -4 minus 2, which is -6. Or you could look at it graphically. If we plug 4 in, our y value is -6. Okay, part 2, they ask you basically to come up with what I came up with here at the top. So I kind of did this for you. What we would be doing is looking at each individual function. So if I'm looking at my first piece, how would we express this as a function? Well, this is just a horizontal line. This would be y equals -2, the horizontal line. For the second piece, this function is an absolute value function. Absolute value functions look like a letter V. So I went through and figured out it's the absolute value function, but it's stretched 2 units and it's shifted down 2 units, so I put a -2 there. I'm actually just realizing in hindsight this might not have been the best place to start. We probably should have done transformations first. We're going to do transformations tomorrow. So if you're having a little bit of trouble figuring out how I came up with this function, please don't worry about it. We're going to do plenty of practice coming up with functions like this tomorrow. All right, finally, the third part of this piecewise function is another line. So you would basically just imagine that this is a line that goes all the way across, and you would figure out what the y-intercept is, you would figure out what your slope is, and you would figure out your line formula in the form mx plus b, which is what we have here, y equals -1x minus 2. So I know I went through that kind of quickly. I hope you were all able to follow along with that all right. Part 3 asks us to think about the domain for each of our pieces. So they call the domains M, N, and P. I actually already wrote the domains out. So for the first function, our domain, or our list of x values, is going to go from -6 all the way up to -3, but it's not going to include -3. So that's why your domain is going to have these symbols: a bracket for your -6 and a parenthesis for your -3. And then I filled these values in here. For the second function, notice we have closed boundaries on both sides. And this function is going to go all the way from -3 up to +2. So we've got brackets for those going from -3 to +2. Finally, for the third function, we've got an open boundary and then an arrow that goes on forever. So this interval is going to have 2 parentheses, one for +2 all the way up to infinity, another set of parentheses, and I've put both of those values in here. Okay, so this is really just a conceptual question to start getting you thinking about piecewise functions, what they mean, how the domain works, things like that. So we're going to do another similar example real quick. This piecewise function only has 2 parts, as opposed to our last one, which had 3 distinct parts. So the first thing they want us to do is plug in some x values. So when we plug in -1 as our x value, our y value is right up here at +2. When we plug in the x value of +2, we have to be careful here. We have 2 options. Are we looking at this value or this value? Well, that's where the filling comes in. If your boundary is open or not filled in, then that's not the point we want. We want the filled in point. So h of 2 would be -7 here, not +2. And then the other point they want us to plug in is x is 5. So we would count over 1, 2, 3, 4, 5, find our y value, which appears to also be 5. So these are the 3 points they've asked us to find. Now they want us to work with the domains again. So this is a piecewise function that contains two different pieces. So we're only going to have two different functions with two different domains. They're calling the piece on the left, they're calling that S, and they're calling the piece on the right W. I don't know where they came up with these names, but we'll call them S and W as well. So for part 2, to answer what S is just the first function in our piecewise domain. So S is going to be the formula or the equation that represents this line. So you just need to find the equation of the line. So our y-intercept is -1 and our slope is -3. Putting that into mx plus b form, you get -3x minus 1. That should not be too bad. For the second function, the second part of our piecewise function, we're looking for w, and w is another line, just kind of goes up in this direction, and you can kind of take the line in the other direction too to figure out what b is, even though obviously the line doesn't technically start until this point right here. But it looks like our b value, our y-intercept is 0, and the slope is +1, so your mx plus b form here would just be 1x plus 0, which I've just written as x. So we figured out what the functions were. Now let's talk domain. So they're calling the domain for the first part of our piecewise function, they're calling it A. So when we want to find the domain A, we're just looking for the domain of this part of our piecewise function. Remember, domain is all of the x values, so pay attention to whether you have open circles or closed circles at your boundaries. It looks like our domain goes from -2 all the way up to +2. Our -2 boundary, however, is open, so it's not included, so we're going to use the less than symbol. And then our right boundary is closed at 2, so we're going to use the less than or equal to symbol. And the way this is written on your screen looks really weird. I'll write it out. It's -2 is less than x is less than or equal to 2. That would be the domain, the x values of the first part of our piecewise function. Okay, now let's look at the domain for w. This domain is going to go, all of our x values are going to, oh no, hold on. All right, the x values for w are going to start at +2 and go all the way up to infinity. However, +2 is not going to be included in that domain because it's an open circle. So this would look like, you could write this in two ways. You could write 2 is less than x is less than infinity. That's one way you could write it. Or you could just write it as x is greater than 2, because it's kind of understood if x is bigger than 2, x will keep going all the way up to infinity. So either of these would be appropriate, but it looks like here they want you to write x is greater than 2. All right, part 4, they want you to find the range. So the range is going to be all of our y values. So we don't have to talk about the range in piecewise terms. The piecewise part of it really just breaks up your x values. But y values, we're just going to look at this as one solid function, and let's figure out what y values are included in our range. So it looks like the lowest y value that is included is this -1, 2, 3, 4, 5, 6, 7, -7. And then all of these y values are included all the way up to here. And normally I would say this y value is not included, but look, it actually is included on the other side. So we're going to have these y values as well. Oops. And then again, because of this open circle here, I'm tempted to say, oh, well, this y value isn't included, but it actually is because, my goodness, sorry, because over here, we have this y value. So this is still included, and in fact, this arrow goes up forever. So all of these y values going up forever and ever are included in our range. So our range begins at -7, and it goes all the way up to infinity. When you write your, oh, they want us to do this in set notation. So we're just going to have y is greater than or equal to -7, and that's our range. All of these marks, goodness gracious, going away. All right, so let's move on to the next question. The next question from the common version that was about piecewise functions was question 5. So if you can find questions similar to this on your personal version, feel free to work on it. Now, this looks quite blurry on my screen, so I'm going to rewrite some of these problems. Hold on one second. Darn it. Okay, so this is supposed to say the piecewise function p of x is equal to -6x if x is less than 0, x minus 6 if x is in between 0 and 4, and then it's equal to 1 over, I think that says x minus 1, we're going to go with it, squared if x is greater than 4. Okay, and I think we need these here. All right, so I can barely see this. So what I've written on the right-hand side of the screen could be accurate, or it could be something I've kind of made up. That's beside the point. We're just going to go with what I wrote, even if it's a little different than what the question says. Shouldn't do too much. It might change our answers here or there, but we can just cross these off and write new answers based on what we can actually see. All right, so assuming that what I just circled is our piecewise function, we want to evaluate f of -4. That means -4 is the x value we're going to plug in, and we have to figure out which domain to use. Well, -4, if we let x be -4, that's definitely less than 0. So if x is -4, x is less than 0. So it's the first formula, the first part of the function that we would use to plug in -4. If we plug -4 in there, -6 times x would give us positive 24. And that would be our answer for that part. I can't read this at all. I think this says 0. So we're going to assume this wants us to plug in f of 0. So if 0 is our x value, then we need to plug it in here, because this is the place where 0 is less than or equal to x. So if we plug 0 in here, 0 minus 6 gives us -6. I think the next one says f of 7. Maybe. That's what we're going to try to find. Let's find f of 7. F of 7 means that x is 7, which is definitely greater than 4. So we would plug 7 in to the bottom. So that would give us 1 over 7 minus 1 squared, which is 1 over 36. And for the last one, I'm pretty sure it's asking us for f of 4. If we plug 4 in, that's also going to have to be to the middle function, because this is the place where x is less than or equal to 4. So if we plug 4 in to the function, we get 4 minus 6, which is -2. Question 7 takes us back to the type of problems we were doing a minute ago, where we're looking at a graph, trying to find some values, but also trying to find the domain. And since, again, I'm having a lot of trouble reading the screenshots that I pulled from these problems, I'm not sure why. I might have to change the way I pull these pictures over. But since I'm having so much trouble reading this, I'm going to kind of ignore the questions at the bottom, and I'm just going to sort of work through up here next to the graph. So we can find a few of our y values. For instance, if we want h of 0, we're plugging 0 in for x. So let's find the x is 0 point. That would give us a y value of negative 1, 2, 3, 4, negative 4. If we plug in 3 for x, if we wanted to find h of 3, 1, 2, 3, we'd either be using this point or this point. Of course, we want to use the one that's filled in, not the one that's open, because the one that's filled in is the one that's included. So that would give us a positive 2. And then if we wanted h of 6, we'd be looking at this point right here, which appears to be negative 2. Now let's talk domain. This function, which they're calling h of x, has two pieces. Our first piece is going to have the domain going all the way from negative infinity up to this point. So I'm looking at this piece right here. This goes down and down forever. So our domain for this piece is going to go from negative infinity all the way up to x, all the way up to or equal to, let's see, 1, 2, 3, positive 3. So that's the domain of our first function. The domain of our second function of our piecewise function is going to just go from 3 up to negative, or up to what, 4, 5, 6, 7, up to 7 possibly. So 3 is less than x is less than or equal to 7. Notice the symbols I use, the inequality symbols. The less than symbol indicates that this is not included in our domain, and the less than or equal to symbol includes 7 here, because that is included in our domain. All right, now I think they probably, so they want us to find the domain on this, but they also want us to find the formulas themselves. So I think, again, they probably call this S, they probably call this W, and we're going to figure out what the functions actually are that represent S and W. Well, S is just a line. It's a line that crosses through the y-intercept of negative 1, 2, 3, 4. So, and it has a slope of, looks like 2 over 1. Rise over run is 2 over 1. So our slope would be 2, x minus 4, our b is 4. So that's our formula. We're just finding the equation of a line. For w, to find our formula here, this is just a horizontal line again at y equals negative 2. So that should be easy enough. So the information contained here should be enough to answer any questions about the formulas or their domains that would be contained in parts 2, part 3, part 4. Nope, part 4 is about the range. Okay, let's talk range real quick. If we want to know the range of this formula, we're going to look at all of the possible y values that exist. It looks like the uppermost y value we could possibly get is this here, 2. And then all of these are included in our range. All of these are included in our range, going down and down forever because of this arrow here. So our range is going to be all of the values less than or equal to positive 2. Y is less than or equal to 2. Or if we wanted to write this in interval notation, remember you always start at the bottom and go up. This would be A, this would be B for our range. We would start from negative infinity all the way up to 2, and 2 would be included. I notice people getting this mixed up with range a lot. Be careful of that. You always start low and then go high. Okay. We've got one more problem about piecewise functions, and this one we can actually read, thank goodness. So they lay out an entire piecewise function here with all of the domains included. So we don't have to do any of that work ourselves. So they give us the piecewise function, and we need to evaluate -4, g of -4. So that's going to require us to figure out where to plug the -4 in. Do we plug it in here? Do we plug it in here? Or do we plug it in here? Well, -4 is going to be in here, where -4 is greater than or equal to -7, but x is less than -2. So if we plug it in here, then our answer is just 4. So that's where we get this. Next part, they want us to evaluate g of -1. If we're plugging in -1 as our x value, we need to figure out which domain to use. I think that would be right here. So if x is -1, -1 is greater than or equal to -2, but it's less than +3. So that's where we want to plug it in. In this case, we would need to actually maybe do some scratch work. If we plug -1 in here, we would simplify this down to -4 plus 4, which gives us 0, which is where we got this answer. Two more to go. If we want to find g of 3, we would plug that into this second domain because x is less than or equal to 3. So we would plug 3 in here. I'm not going to actually work that out, but if you plug 3 in, you end up getting the same answer we just did, which is 0. And finally, we're plugging in 5. And if we do that, that puts us in this domain because 5 is greater than 3. So we would end up with 5 halves plus 1, which gives us 7 halves. All right, the next thing they want you to do in this question is determine which one of these visuals is correct. So I'm going to start with looking just at the domains. For instance, I can see that my domain's going to go from -7 to -2 parentheses, -2 up to 3 in brackets, and then from 3 to infinity parentheses. So my graph should look like this. This should be solid, not solid. This should be solid. Just looking at the domain, the middle piecewise function should have solid circles, filled in circles on both ends. So this is already out. So we know A is not the answer. And for the same exact reason, we know B is not the answer. Okay, hold on. These graphs have a mistake. Based on the domain given, the actual answer key has a mistake on it here. Did you notice that no 4 of these middle segments had 2 filled in circles? But they both need to be filled in because of this. So they made a mistake. Sorry guys, I hope that's not too confusing. Let's, instead of looking at the domains, which they've made mistakes on, let's look at the functions themselves. Our first piecewise function is just a horizontal line at +4. So all 3 of these look good. -1, 2, 3, 4, 5, 6, 7, -7, 7. These all look fine. Our domain actually switches, or our piecewise functions, we have 3 separate functions, should switch from one to the other at the points -2 and +3. So note here, this is where our first function should switch. So a is wrong here. -2 is where that switches, that's good. -2 is where that switches, -2, that's good. And then they should all switch at +3, +3, +3. All right, so far we've only been able to eliminate A. Let's talk now about the second piece. So we haven't talked about transformations yet, but this is a quadratic equation. It has an x squared in it. I know it's kind of hard to see, but if you imagine foiling this out, we'd have an x squared minus 2x plus 1. So an x squared is going to look like a parabola. But more specifically, if you have a negative sign out front, it's going to look like a negative parabola. So this one's out too, because that's a positive parabola. A few other things we can do to kind of test which one of these is correct is we can actually find these values on the graph, the ones that we already spent time finding. So we could look for g of -4. We could look for g of -1 is 0. We could look for g of 3. And we could look for g of 5. So 1, 2, 3, 4, 5. That looks to be about 7/2. 1, 2, 3, 4, 5. This is definitely, not positive 7/2. So just some things to look for to try to figure out which graph is right. Definitely going to go with B here. Okay, so this is the last problem I wanted to do today, and then I'll let you guys work on your work independently for the rest of the class session. This is basically a step-by-step way of thinking about a piecewise function. You're not going to see these very frequently, and it's easier than it looks. It looks kind of complicated. But you know, when we were talking earlier, if we had a function like this, we would call this s of x, and we would call this w of x. We're basically thinking about this problem in the same way, where this is kind of like an s of x. It's just way easier than it looks. So ignoring the first part of this really quickly, let's look at what they actually want us to find. They want us to find g of 1. So that means I'm going to start with g of x. So I'm just going to rewrite g of x. So all I've done is just taken this and rewritten it. Since I'm looking for g of 1, I'm going to plug 1 in here. So I can write this as g of 1 equals 2f of 1 plus 8. So, plugging 1 in for x just means replace all your x's with 1's. So at this point, we're kind of stuck. We can't really simplify this anymore given the information we've pulled out of the problem. So let's see if we can go find some information about f. Well, it says here that these points lie on the graph of f. If this is a point in f, that means when you plug in 1 as x, you get out 3. Or another way to write that is f of 1 equals 3. The x value spits out the y value. So f of 1 is 3, based on the fact that we know this point exists on f. So I'm going to rewrite this as g of 1 equals 2 times 3 plus 8. And that simplifies to 14. So that's it. That's how you get 14 here. Really, the only trick to this was figuring out what f of 1 was equal to using this point. So let's do this the same thing basically with h of 1. So here they're asking us to find h of 1. So we're going to start with h. h of x equals f of x minus 1 plus 2. And since they want us to plug in 1, we're going to put that in for x. So everywhere you see an x, leave a blank, and just replace that with a 1. So on the right-hand side, we can actually simplify this just a little bit. F of 1 minus 1 is the same as f of 0. But now we're kind of at a standstill because we can't simplify this anymore without additional information. So let's find some information. We're looking for f of 0. Well, we're told that the point 0, 2 lies on the graph of f. So that tells us that f of 0 equals 2. When I plug in this x value, I get out this y value. That's what a point is, x, y. So f of 0 is positive 2. So that's where we get just 2 plus 2, which gives us 4. Okay, that concluded the piecewise functions conversation I wanted to have today. This has been recorded, so I'll be posting it on YouTube in a little while, so feel free to refer back to it later if you need to go over any of these problems again.